Hello, my name is Lemur Sunil and welcome to my video series where I'm developing a game. In this video, we're gonna look at the car AI. So right now in my game, there's nothing on the roads that runs around. So what I'm gonna do is I'm gonna implement some cars that's gonna drive around the map and make sure that they don't crash into each other or there's cars stuck in traffic and so on. So it's just gonna give the city a bit more life to it. So what we're gonna do is we're gonna look at a waypoint system. And the waypoints are kind of the fundamental idea that will enable the cars to actually drive around the map. And we're gonna look at the waypoint network. Building the entire map and connecting all the waypoints in such a way that the cars can drive around looking like a real life traffic rules real life traffic basically. Okay, so how is this waypoints system gonna work? Let's draw a bunch of stuff here. This is one of the squares, and we'll have the road kind of go around like this. And I'll just draw like I'll just draw a boundary. Let's just make this simple math to map to explain how the system will work. So this is the road, and this is like the map with all the buildings and everything. All right. Now, what I'm thinking is, let's say we have a car. The car is going to drive on the right side of the road. So we have a car over here. So the car is going to drive in this direction. And we're going to have waypoints along the road. So we're going to have a waypoint here, a waypoint over here. So for this simple example, it's quite straightforward actually. Okay, so the idea is that the car will move towards a waypoint, so it will have like a target. Let's denote the target as red. So this is the current target of the car. So it's gonna move towards that target in a straight line like this. So once it's reached the target, it's gonna want to pick a new waypoint to travel to. And let's say it's this waypoint down here. That will not be a target anymore, then this is gonna be the target. And so then the car, it was over here and then it rotates and then it drives along here and so on. So you can place the waypoints around the map. So that's basically the idea. And these waypoints, they need to be connected as well. So we're gonna do this waypoint connected to this waypoint like this. So it's like a graph which has direction. This is connected over here. Then we also have waypoints over here and over here. And this guy is connected over here. So this basically determines the direction of the car where it's going. All right, now for the other side. Okay, so this is all good for this simple kind of example. However, I'm gonna make a new example here. Okay, so for this example, we actually have a road that is a bit more things can happen here. So how will the waypoint system look here? So we will still have these corners out here and they will be connected. So they will still be connected like this. And the inner ones are also connected like this. Okay. However, we also have this three-way intersections here. And there's actually a couple of different scenarios. So you have one scenario is where you have a car that comes from over here and he wants to make a left turn. So you want to go this way. Then you have another scenario where it just continues straight forward. And then there's another scenario where you come from this way instead. And, well, you just want to go straight forward. And then there's another scenario where you want to turn right here. So, and then there's even more scenarios. So there's one scenario where you come from down here and you want to turn right. There's also a scenario where you want to turn left. There is a bunch of different scenarios here. The way I've opted to solve this is that you have a waypoint over here, and when you come from below, it's gonna be connected. So if you have this as a target, you're gonna end up here, and so this guy is gonna be connected over here as well. But then you also have a red arrow up here, and for that we're gonna have another waypoint over here. And also note that these waypoints are not connected right now. They're not connected to anything. This line actually goes like, well, it goes straight over here, but it's not connected to this. However, when you go here, this is also connected to this. And then this is also connected to over here. All right. So in this scenario, we go turn right. We come from down here, we turn right. And in this scenario, we turn left and go to this part and then goes over here. So this waypoint is actually only connected to over this waypoint over here. So the only thing you can do when reaching this is go over here. All right. Now, and also this waypoint is connected to all the way over there. But what if we want to turn, what if we want this green scenario? Well, then we have a waypoint over here. And we connect this up to this as well. And then we have a waypoint over here. And we connect this green one to that. And so if you from this waypoint, you can either go all the way over here, or you can go to this waypoint and then to this waypoint, and then you continue straight down here. And from this waypoint, you get all the way over here, or you can actually also get, oops, you can actually also connect to this guy, which will also go down here. So this is kind of how the graph is kind of implemented here. So now we've implemented all of these situations with these waypoints that we have here. And this is as far as I'm gonna go with complexity of the waypoint network. There is a little bit of extra things that you have to do to make sure that when a car wants to go out here, that there's not gonna be a traffic, that no one gets stuck in traffic here. So you need to apply some certain rules to make this work smoothly. However, this is a foundation that you can build on, where you have at least where the cars want to go in this way. I'm gonna show how to fix the issue where, let's say, a car comes up from down here. So let's say we have a car that is driving up there in this direction. And then we have a car coming over here. We're coming from over here. And this is gonna go over here. And this one, let's say this one wants to turn to the right or to the left. It doesn't actually matter. But when a car comes out from here, since this intersection is kind of, yeah, I'm gonna draw it how it looks in my country. We've got these shark teeth, as we call it, and that means that when you get here, you have to leave precedence to these cars that comes from this side. So you come from here, you see these teeth on the ground. That means you have to stop, or, well, you have to see if there's other cars coming. and you stop if there's other cars here. So this guy has to stop to let this guy pass here. And it's also true if there's cars coming from this way, but let's focus on this first. So what we do is that we actually have a special waypoint, or well, not really special, but it's another waypoint that's actually below here. And this is the actual waypoint that we have here. So this waypoint is also connected from down here. And this waypoint has a rectangle which looks like this. So let's say we have a rectangle that looks like this. So everything that's in this blue rectangle, it's a bit busy here with the graphics here, but hopefully you see this rectangle here. This rectangle, when you come to this waypoint, this rectangle is going to get activated as a leave precedence mode. And if there's any car in this rectangle while this mode is active, this car that reaches this place is going to stop, brake. And then wait until there's nothing in this rectangle. And once there's nothing in this rectangle, then this car can proceed to the next destination. All right, so that's how we deal with leaving precedence when coming into this, because otherwise, yeah, you might have a crash, you might have people getting stuck in traffic and so on. A whole lot of problems. So this is basically implementing sort of a little traffic rule, basically, to make sure that traffic runs smoothly. All right, so let's look at the code for waypoints. So here's the struct for a waypoint. And here we have these links, which you can have up to 10 links. So this links is an array of up to 10 links with nullables or options for these entities. So the entities are actually, yeah, a waypoint. So the thought is that this is actually a component which gets added to an entity, and then the entity is basically becomes a waypoint. So we can link to the other entities like this or other waypoints. Then we have the precedence rectangle. So each waypoint has this precedence rectangle, or it has no precedence rectangle. If it has a precedence rectangle, then that will come and play in the logic later. Here we define the max links to 10. Here we have the init function where we basically set everything to null. We have a connect function which connects the waypoint to another waypoint, and it also checks if we have the link already, then we don't need to do anything. And then we get an available link and set it to the destination here. Okay, and then we have some other utility functions that we're gonna use later. So let's look at how this is used in the CarAISystem. So here's the CarAISystem, and there's a bunch of stuff in here, and a lot of these things, well, most of these things has to do with like car physics. Well, actually, these three are like car physics things, and then these three are actually part of the what I call the car safety awareness system, which is basically just, is there a car in front of us, then we brake. If there's a car too close in front, then we brake, basically. That's the whole system. I tried to implement a more intricate system, but I ended up just using this part. Okay, so here we have the CarAISystem, the update function, which is called every frame from the main loop. And we loop through all the cars, which is basically this CarAI rigid body group, and we iterate through those, and we update each car individually. And so here we do a bunch of these updates. So we have navigation, which updates, like if you reach the next, well, let's look at it. So yeah, this checks if you have reached the waypoint, and then it selects a new waypoint. So that's basically what it does. So we have tolerance, which is like how far away do you have to be to a waypoint to actually count as you have reached it. And this is like 5 pixels. Yeah, then we get the waypoint body here and the distance to the body, to the waypoint. We check if the distance is less than the tolerance. If so, we get the waypoint, and then we have actually reached this waypoint, so we need to handle that. So what we do is, well, here we are dealing with the precedence rectangle. So we're checking if there is a rectangle then in the waypoint that we actually, I think the waypoint that we have left. Yeah, it's either the one we had left or the one we reached. I don't remember which one it was. But anyway, we remember that we have a precedence rectangle here. And that will come in play later. So then we also randomly select a new destination. So it goes through all the links from a waypoint. So if it's connected to several destinations, several waypoints, then we just randomly select one of those, and we're gonna just get that link. And that code looks like this. So we have the get random link. So we get this random struct in here, which has a bunch of random functions. So first we count how many links do we have. Then we take a random number from 0 up to, but not including the length, with this uint less than function. And then we return the link that, we return the actual entity of that random link. And then we assign the new link, the new destination, to the waypoint of the AI. Oh yeah. Also, I haven't gone through the CarAI, but it's over here. It has a bunch of different things. But we'll go through that. I think we'll go through that later. Let's see. Let's continue here. So we've got, we get the waypoint body. We get the relative position from, I think this is the car body. Yeah, the car position to the waypoint. Right. So that's to get the actual direction to the new waypoint by using thisatan2 function. And you pass in a y and an x, and you get the direction that you need to go to the new waypoint. All right. So that's it for the update car navigation. Then we have this car intent, which yeah, so this is kind of following rules, avoiding crashes. Yeah. So we have basically a couple of different modes. So we check here, do we need to follow local rules? And that just means right now that you have the giving precedence rectangle. So if you are currently giving precedence, then if you're not giving precedence, then we don't do anything. But if you are giving precedence, then we check, are there any, we get all intersections and we free it with the defer, and we loop through, and we want to check if there's any cars or if there's anything actually inside of this precedence rectangle. And we also check if it's not ourselves, and if it's a static or if it's not solid, then we don't care. But basically just something that's in the way and that you can crash with, basically, and not yourself. If there is anything like that in the precedence rectangle, then we just return true, which will denote that we are following local rules. So that's the mode that we are in. So we're basically braking in that case. Otherwise, yeah, here we're setting the state to accelerating. We are doing that because I think we need to in some cases. And then we also return false. So if this is true, that means we are following local rules. So we don't want to do anything else. That takes precedence over this other stuff. If it's false, then we continue down here and check, are we trying to avoid a crash by not running into a car that's in front of us, basically. So that's what this is doing. So we're getting a circle this time that is like in front of the car where the car is going. So basically, if you're driving, you're checking in front of your car to see if there's another car in front of you. Are you close enough to that car? Then you apply brakes until you're not close enough to that car anymore, and then you can start driving again. So we're taking this circle, we get the intersections here, and we free those up, and we loop through them. Basically the same thing as the other one, except that if we actually find something in front of us, then we set the state to be braking here. Okay. And then, yeah, I also have this other system here, which is not in use right now. So let's not go through that. And yeah, if we are avoiding the crash, we need to return. If we're not avoiding the crash, then we are driving normally. And driving normally basically just calculates a bunch of stuff to make sure that you're reaching the waypoint. Yeah, we handle a whole bunch of stuff. I had to fiddle around with this a lot to make the cars actually turn nicely and accelerate and brake and all of that in a nice way to make it look nice, basically. So I spent a bunch of time on that, but I'm not gonna go through all that. It's just too much. Oh yeah, and then we have physics, update car friction. Yeah, there's a whole bunch of stuff with that. I'm not gonna go through the physics right now. This is mainly about the waypoint system and the network system and the animation as well. So that's basically all we're doing with the car. Well, there's a lot of stuff, but I mean, and this system isn't even that complex, to be honest. It's like you can make it even more complex. I mean, you can have like traffic lights, and you can have a whole bunch of different rules when, like, yeah, when driving. Like you can have different precedence rules and all of that. But I'm not gonna implement that. I'm good with what we have right now. And so yeah, that's basically everything regarding the waypoints. And so if we actually go in and try this out. All right, there we go. Okay, so now you can see the all the waypoints and the cars driving around the waypoints. So, and you also see the precedence rectangle here. So if I were to, now there's a green car coming here, so if I go into this precedence rectangle, you can see that the car actually stops here, and when I drive out, is gonna drive out there. All right, so that's basically it for the cars. Now I'm gonna show also, I'm gonna add the music, which I've already implemented, or yeah, I've already implemented it basically. So I'll just show you how I implemented the music. So first I get this music struct, which I defined like this. So this is basically the pattern that I use for all the textures and sounds. I have this function, which is a generic function, and I have this struct. So this is way too complicated for this actually, but it's like, yeah, you just have, just think of this struct where you can put anything in the actual stuff. So this is basically just a way to have this dictionary set to some type. So we have one music, which is called theme. And the way you use this is you say, yeah, I want the paths for all the musics or the music. And then you would call this and you put in, this is a string with a zero terminated string. And then you just put in, this is the theme. I have a root directory, and this is just the directory or the file name here. So, so that's what the music path is, or the music struct. Here we have another struct which contains the actual music that we load into the game. And this type is music, and then the Raylib music inside here. So that means that the theme will have a Raylib music type. And here we load this, and I'm using a bit of comp time stuff here. So I'm going through all the fields of the music, which is basically just one now. It's the theme. And I'm using the standard meta fields, which gets all the fields of a struct into an array. And then you can access stuff with this field, for like name, for example, by so that you can use to access actually this at field will access a field of a struct. So this is a struct value, the music paths, and this is the field that we want to access. So this will basically correspond to, since there's only one music, this is basically going to correspond to music paths.theme, and this will also be scene.music.theme is equal to music. Yeah, so this will basically compile into this, since there's only one theme. If there's more music, then it's going to compile into another one theme too, like this. That's basically what this code up there is doing. Okay. So what we're doing is we're calling Raylib load music stream, which just loads in a wave file, and it sets it to this field that we pass in here, the pointer. Then we also set. Oh wait. Oh no, sorry. This loads in this path that we have. This is music paths, yeah. So we're accessing the field name of music path to get the name of the file, which in this case is busy-taxi.wave. And then we also have this part which sets the actual pointer to the data that we fetched. So, or maybe it's not a pointer, but anyway, it sets the value here. And then we also adjust the music volume. For now, we just set it to 1. The sound volume I've actually lowered quite a bit because it was quite loud. And that's how we load in the music. Okay. And then here, to actually play the music in the start function, which is called 1 time per level, I think, we call play music stream. So this is how you start up the music. And you pass in the Raylib music that you want to start. Then that's not enough to actually play the music. So you have to have update music. So in each frame, you have to call update music stream for each music that you want to play. Now let's try this and see. And you can hear the music playing here. Okay. Yeah. So I'm actually gonna be happy happy with that. So yeah, I'll consider this being completed now, or I'm gonna move on to another project, another game, which I'll also upload and show the development in. So thank you very much for watching. Comment down below if you have any questions or anything around Zig or anything else. Have a nice day and see you. Bye.